So, hello everyone. Today I want to explain about the second part of the 2A ANOVA. So, in the first part of 2A ANOVA, we run the test with the two independent variable and then one dependent variable. The result was the significant with the your performance appraisal scores depending on the gender department and then the interaction between the gender and department. So you can see that all of them are significant. And then together, they have the atmosphere effect size is 37%. So this model explains the appraisal scores about 37%. So here we have the interaction significance level and then also the gender and department. So in this case, when you obtain this result, you can see the post hoc, etc. But here you can see the gender, man and woman. It shows the significant big difference between the claims and the sales in the both of them. They have the big differences, and also the in the women and women, they show that here that it's a man is a blue and then woman is the pink color. So women are not very significant difference between the five departments, but the men they show the, in the finance and claims much greater than other departments. So when you obtain the result in this table of the between subjective facts significant, and then you want to know more details how it's possible this result uh, happens, and then we will investigate more about the other details. So we have to go back to our data, and then the gender and department were independent variables, and now we will go to the data and then split file, and then you will organize the groups you can remove the effect of the one independent variable and to check only the second independent variable, how they produce the result. So here first let's start by the first variable was the gender. So you put the gender here, and then now we remove the effect of the gender, and then we will see what happens with the according to the department. So here you do okay, and then we run the ANOVA test now. So analyze general linear model univariate, and then you can put the performance score here, and then now we split the file with the gender. Now we will go only the department. And then here, everything you check with the model 3, and then the plot, you can put the department horizontal axis, and then add, and then continue. And the post hoc, now it's a department, you can have the post hoc test because they are more than 3 groups. So LSD, and then when it's a homogeneity is not assumed, you can check the next C. So continue, and then save. You don't have to check anything. That is a default. Options, descriptive, estimated, and the homogeneity test, and then continue. And then you can run the test. So when your gender is a constant, they split the file as a man and woman. So now you can see the only man. What happens with the department is only man. So here you can see these five departments are different numbers. They have the different numbers in men in each department. So the claims they have the more men than other departments. And then in the descriptive administration mean and then the technology mean, etc. So the claims the mean is higher, and then sales mean is the lowest. So you can find it from here, also descriptive. And then Levin's test shows that it's not it's significant. So this means that homogeneity was not assumed. So you will consider the post hoc with the NET-C as a post hoc test because it's a significant level of the Levin's test shows that homogeneity was not assumed. Okay, so here you can see the department is a significant level in the man we split the file as a man and woman. So now we are looking only exclusively about the man. So for men, department was a significant difference means between the five departments. So you can consider that here the which one was the claims and the sales are significant difference, and also other departments we can consider that they have a significant difference. Now we can find here exactly from where is coming the difference. So you can check the asterisk here, administration and claims, that was technology and claims, and also the technology is the finance, and finance technology, and then finance sales, etc. So as I said in the part one, when you check your post hoc, don't repeat the same thing it was already done. This means that technology and the finance is already, we said that that is significant, and when you go to the finance and technology, it's the same thing. So uh, avoid the same repetition and then just check what was not said. For instance, here the sales, they have many significant difference with claims, for instance, administration claims, technology claims, and the sales claims. Okay, so when you said one this and then the others redundant thing, you don't have to say. So as the homogeneity test, what is significant, you have to see the next C, but unfortunately you don't have any sign about which one is significant, so you will just check the same LSD but follow the asterisk. That is the about the next C. So you can find that by that way about the significant difference by post hoc, and then you can see here in fact, this is about the men. They have the finance and the claims are much greater than other departments. So really, that means the big significance compared to the other department is only concerning the men. Now, as we split the file concerning the women, let's see what happens here. You have the mean difference here, and you can see it's not remarkable change like men. So they have the small variation of the means. Levin's test shows that it's not significant. So this means you will follow the LSD as a post hoc. And then department here, however, significance is not significant. So this means that among women, the mean difference according to the department is not significant. So you don't have to interpret the post hoc because the test itself is not significant. So let's see the plot. Okay, so here is the plot of for the women, and you can see that administration and the sales are different, but it's not like men. It's a very peak score and then the very low score. So this difference, considered that it's not so significant as a mean differences. So this is the result of when you make your gender constant and the only department. And now we can go back to the data and then split the file. And then you go back, you make the back your gender. And now let's department as a split file. And then you do OK. And we can now run the Anova test when the department is constant. What happens in the between men and women? So analyze and general linear model, univariate, and now department is already split. So we will go for the gender. What happens in the gender? So here post hoc you don't have to think about because it's only two groups. So we don't have the post hoc. So just you can run the test. And now what is happening? We will see the result according to the department. So as a administration, you can see here the men and women. They have the number here, and the mean difference is 34, 33. It's a very small difference. So that's why the significance is not significant. So the difference between men and women in administration is not significant. And now the department of the technology, men and women, they show that 30, 30, yeah, this is also. So that's why your test gender is not significant. So don't worry about that. And then the finance department, let's see. Men is 41, women is 31. So it's a big difference between the men and women, women in the finance department. That's why the significance is showing the significant difference. And then that is here the 29%. It's explained about that. And the claims, you can see that the 4330 is a greater, much greater than the other finance. So claim here also you can see the significant, very significant. So the mean difference in this department about the claim department between men and women is very great. Sales, they have the men 30, women 28. It's not a big difference. Just you can see that. And then the significance level proves that between gender in this department of the sales, there is not a very big difference. So you can conclude that with this, we didn't check the in fact the about the analyze, and then let's just see about the plot. We didn't do that. So evaluate, and then the plot. Yeah, you can put the gender and then add, and then the continue. Okay, we can do that. So we can check now the same result, but about the plot. You can see here the women are much less than the men in the performance appraisal scores in the department of sales. But also you have here the another plot about what is this department is claims. So you can see here also the men are much higher and then women are less. So when you check the each department, they have almost the same sort of the plot. So this means that you cannot really know by the plot how much is the difference. So you will just check by the this table of the about the significance about the if each department shows the significant difference between men and women. You can just check by that table. This is much more practical and watching the plot. However, when you check the plot in the I will show you that in your yes. So when you make the constant your gender according to the department, that is much more clear to find the how the when gender is constant, the department scores are changing. So this is about the part two of the TOEIC ANOVA. And when you in the summary, when you obtain the significant result of interaction of the TOEIC ANOVA, and then you can make the each independent variable as a constant, and to obtain the details and to find where exactly the result come from. Thank you very much.